Yeah, so like I said, I'm going to be talking about how we can potentially use Arrow and Beam together to do some columnar data processing at scale. So yeah, first introduce myself. I'm Brian Hulette. I work at Google. I'm a committer on the Arrow project, and I am a lowly contributor to the Beam project. I've been working with Beam since, I think, February, since I joined the current team I'm on at Google. Yeah, that's me. Oh yeah, what I wanted to know is, so my contribution to the Arrow project was I actually mostly worked on the JavaScript implementation, so, you know, I wasn't too down in the weeds. It's kind of a weird way to get into the project, but it let me make some pretty pictures, so that was cool. So my agenda for today is, first I want to, I'm going to we're at the Beam Summit, so I'm going to assume that most people have some kind of working knowledge of Beam, so I'm sorry if that's not you, but I'm going to jump into first an introduction to what is Arrow, since most people might not really know a whole lot about it, or might just understand it at a high level. And then we're going to get into why we as the Beam community should care about using Arrow in our pipelines. And then I also have some benchmarks that I want to show you about how performance improvements that we might be able to get from that. And then also talk a little bit about how we might start to use Arrow in Beam in the future. All right, yeah, so first, what is Apache Arrow? So I sort of think of the project as three distinct things, distinct-ish things. So the first thing is that it's a specification at its core. It's really just a specification for an in-memory format for data. So in that way, it's a lot like a project like Parquet or Orc, where it's just built around like some file format. But the key difference with Arrow is that it's an in-memory format. So like the format is not intended for long-term storage. It's for data that you have in memory or maybe are transferring between processes. So like maybe as a wire format or primarily as actually like an in-memory format. And it's a specification for a columnar format. So that's important because it gives you potential performance improvements. And I'll get into that in a little bit more detail. So the second thing that Arrow is specification by itself isn't particularly useful. So in Arrow, you have reference implementations for in a variety of different languages for this format. I'm not sure that I actually even have the entire list there. Like it seems to grow super fast. The most mature one is C++, and Java is also very old. Those are both native implementations. A lot of the other ones are actually just like bindings into the C++ one. But then there's more native ones. The JavaScript one is a native implementation. Rust is a native implementation. But so all these are implementations to read and write the same in-memory format. And then finally, the last thing it is once you have this core foundation of an in-memory format for your columnar data and ways to produce and consume it in different languages, people want to do cool computation things on top of it and do interesting things with it. So people have started to add interesting computation libraries and various other sub-projects to Arrow to do things with the Arrow data. So I'll go into each of these things in a little bit more detail. So I mentioned that Arrow's specification for columnar in-memory data. So if you don't really know what that means, basically the high-level view is if you have tabular data, so data with like rows that all have some attributes, if you want to lay that data out in memory, there's kind of two different ways you could do it. You could kind of take the traditional approach where you first put all the values for each row together in memory. So you first put all the values for one row, and then the next row, and then the next row. It's also called like a row major approach. And that's nice because it's easy to reason about. It's easy to find a particular row that you might care about. Everything that's related to each other is all together. But with a columnar format like Arrow, or also some of these file formats like Parquet and Orc, they say like, no, that's too simple. We want to make things confusing, so we're going to transpose it all. So when instead in an Arrow buffer or any columnar format, you would put everything for a given attribute in a single array in memory. So first you would have all the values for, in this case, section ID in an array, and then timestamp, and then source IP. And then what that gets you is that in your sort of common data access patterns where you're actually just like scanning over a couple of columns, maybe not accessing all of the columns at once, you're not polluting your cache with data that you're not actually using like you would be if you were scanning over your traditional buffer. And then also because all of your data that's like of the same type is together in memory, you can start to do vectorization and use like SIMD instructions. So that's like single instruction, multiple data. Like so you can do things like multiply 4 numbers together in a single processor instruction. So you can just get big performance wins that way, like just for free, like 4 times performance improvement, which is great. But yeah, so like I said, the problem with Columnar is that it's a little harder to reason about. So if you have a traditional memory buffer, it's really easy to just add more data on the end, just add more rows at the end. But in Arrow or any columnar format, where do you put another record? Like, do you want to copy your buffers and move them a little bit and insert some things in there? Like that would be pretty inefficient. So the most common approach is in any kind of columnar system is you do batching. So in Arrow, this is like what the streaming format looks like. You would first send a schema, so they have like a portable binary representation for your schema that defines like what all the fields are and what their types are. And then you would start to send just batches of records. And each one of these batches would just look like that Arrow buffer there, where you just have an array for all of your attributes. And so that is to say, basically the fundamental unit of data in Arrow is a record batch, right? So you just have record batches of n records together. And so that's an important thing to realize when you're trying to do columnar processing. All right, yeah, so coming back to the first slide, so the other thing that Arrow is implementations for this columnar format in memory format in a bunch of different languages. And what that gets you is it starts to make it so that Arrow is a common data layer. So, this is a picture I took from the Arrow website back in the olden days, in the olden times before Arrow. What you had to do is you had all these different projects that all had their own different ways of representing data. And if you wanted to move things between them, you had to like convert it and copy it to some serialization format, move it over, copy it again, and deserialize it over on the receiving end. But with Arrow, the idea is that all these systems will operate on the same in-memory format. And so if these systems are operating on the same machine even, they could read from the same like shared memory. Or even if they're not on the same machine, you can use like the Arrow wire formats to actually transfer data between them. And then on the receiving end, you just read the data directly rather than having to deserialize it. So you can get, so instead of wasting cycles doing like serialization and deserialization, you just move the data around. Yeah, and you'll notice there's a lot of Apache projects on this graphic that just happen to be on the Arrow website. The only one that's not is Pandas, but also Beam is missing from there. So I think we should get that on the chart. Yeah, so the last thing that Arrow is computation libraries sort of built on top of this format. So there's a few different things within the Arrow project right now that are all sort of in progress. Gandiva and Data Fusion are maybe the most complete ones, but so there's C++. It has a compute library within their library, so it can do has some basic computation kernels, so it can do some aggregations and sorting and filtering. That's still sort of in progress. They're still adding a lot more capabilities there. There are also plans to add like some data frame functionality to C++, and so. You can start to do things like if you're familiar with the Python Pandas library, you can do things like that from C++, and they'll have bindings in Python, I'm sure. Gandiva is a really cool project, sub-project contributed by a company called Dremio. So what that actually does is you give it an expression tree. So something like, if you have an Arrow record batch with like 3 columns, A, B, C, you give an expression tree that's like, I want you to compute A times B, and C minus A and B divided by A times 3 or something like that. You would give it these expressions that you want it to evaluate, and then it uses LLVM to generate optimized code to perform those, to compute those expressions on Arrow record batches, and then you can churn through some data with it. So there are bindings for Gandiva now in C++, Python, and Java. So you can actually use Gandiva right now to do those sorts of things. There's also an interesting project called Data Fusion that's in the part of the Rust library. So that adds an in-memory query engine that's based on Arrow. So the way it works is basically you just give it a SQL string, and then it can execute that SQL string on Arrow data. But it's intended just to operate on a single node. It's not any kind of like distributed thing. There are also some interesting external projects based on Arrow. So NVIDIA has this like Rapids CUDA data frame, GPU data frame spec, and their spec is actually just Arrow. So they just will. So if you have the system where you have Arrow data all over the place, you could actually potentially accelerate certain steps by using GPUs, by using some of this CUDA code that NVIDIA has already provided for you. All right, so enough about Arrow. Why should we, as the Beam community, care about using it in our project? So the first thing is, I just told you about all these cool computation things. Like, I want to use them. So if we use Arrow and Beam, we can start to actually use all of these things. And there's also already been people have shown some big wins by using Arrow in their projects. So like PySpark had, I guess, made news. I think it was like late 2017, where they actually added the ability to write vectorized UDFs using Arrow. And so they actually, in that case, they used Arrow as an intermediate format between their internal columnar format and like the pandas columnar format. But still, since it's like columnar all the way through, it was just still pretty fast. And so they were able to bring this data into the Python context and let people execute Python vectorized functions, like do things with pandas and that sort of thing. And they reported a variety of different performance improvements depending on the operation, anywhere from like 3 times up to like 240 times. It's kind of crazy. The other reason that Beam should care is like I feel like these two projects have very similar goals. Like we're trying to break down barriers between different languages. Like Beam, we want you to be able to use whatever SDK you want to use, whatever your language of choice, and run it on any runner that might be implemented in any runner. And Arrow has a similar goal, right? We have implementations for the same in-memory format in a bunch of different languages. And so, they're natural things to use together because we can actually start to do cross-language things with columnar data. So another reason is we're starting to add this concept of structured data to Beam. So, historically we didn't care too much about like what your actual data looked like, but we're starting to add schemas and SQL and schema-aware transforms to Beam. This is primarily in the Java SDK right now, but there's interest in making it portable and extending it to the other SDKs. And I think that's a very natural place for Arrow to fit in, since it's a representation for your structured data. So finally, another thing is there are actually many sources that we have in Beam today that could be read in as Arrow record batches instead. And so that's something that people could actually start to do now. So like Arrow has readers for these common data formats like Parquet, CSV, and ORC, where you actually, you read in a data file and you get out an Arrow record batch, and then you can do some computation on that. And there are similar things. So in the BigQuery storage API, they actually recently added the capability to get your data out of BigQuery as in the Arrow format. Previously, you had to use the row-oriented Avro format. I also, this week, learned that Apache Iceberg, I guess, is a project to add tables that are backed by blob stores. They actually produce Arrow record batches as well. So that's something that we could actually start to use today. That's one thing I wanted to dig into a little bit more. It's like if people started to do that, what sort of performance improvements could they get? So that's what I started to benchmark. So I wanted to kind of benchmark sort of a typical use case, and I talked to my boss Ken about it, and he suggested I use the TPC-H queries, which is TPC-H is this common benchmark for database systems, where they have ways to generate a bunch of random data and then say like run this SQL query on it and tell me how long it took. And so I ran the first. I wanted to build a pipeline to execute basically the first SQL query that is part of the TPC-H standard. So this is what the first one looks like. Basically, it kind of has like all the classic bits of a SQL query. It's just like doing a group by on these certain fields, and then it does a variety of aggregations. So aggregations on some fields, aggregations on some computed columns. There's a filter on the date, and so it sort of has all the various bits. So it is a relatively interesting use case. So What I did for my benchmark is I generated a bunch of data with the TPC-H dbgen tool, converted it to Parquet, and wrote it out to Google's GCS. And then I wrote 2 different Python pipelines. So it was just easiest to prototype with the Python SDK. So I used I used the read from Parquet transform, which exists now in Beam. And that is a transform that reads from Arrow and produces like Python dictionaries. And then I wrote another one that uses read from Parquet batched, which is something that I have a PR up to add to Beam now. And that basically just produces an Arrow record batch per Parquet file. So instead of like actually splitting it out into Python dictionaries, it just gives you an entire batch for the Parquet file. And then I compared the performance for these 2 runners running on Dataflow, and then also compared the performance for these 2 pipelines on 2 different runners, on Dataflow and on the Flink runner running on Dataproc. So this is what the 2 pipelines look like. This, the element-wise one is pretty simple. You just do the read, and then does the filter by the ship date, adds a key, then does all of the combines and aggregations. So all of the like computed columns and combines and stuff are all combined in that combined fun. So in the batch pipeline is a little bit more complicated. So now you'll see we do this read from Parquet batched, and that produces a P collection of Arrow record batches. So that's important. Like now these are actual batches of multiple records together. And then another thing is the very first thing I do is actually convert this record batch to pandas. Ideally I would actually be doing some like Arrow native computation rather than converting it to the pandas format, but this was just, for prototyping, this is the easiest thing to do, and it's a relatively inexpensive operation. So yeah, convert it to pandas, compute the computed columns, do a filter, and then this does all of the aggregations and combining here. And so you'll notice I actually have to do this. It takes 2 steps because I first have to aggregate the individual record batches. So that's doing this pandas group by, and then doing the actual Beam aggregation. So yeah, so what kind of performance improvement do you get here? So it depended a little bit on the runner. So first, running on Dataflow, I just fixed it at 2 workers, so the auto scaling didn't cause any variegations. And then in that case, you got a 4 times improvement from the batch pipeline over the element-wise pipeline. So a far cry from 240 times, but it's still pretty. If you can make your pipeline 4 times cheaper, that's pretty great. Then I ran the same thing on the Flink cluster, and in that case it got a 3 times performance improvement, so same order of magnitude. I also, this week I was like, man, people are going to laugh at me if I start talking about like 2 worker clusters, so I figured I should scale it up, so I just decided to just do everything 100 times. So I did 100 times as much data, ran it with fixed at 200 workers on Dataflow, and in that case it actually was a little bit better, 6 times performance improvement. So this is great. Mission accomplished. We have Arrow and Beam now. Talk over. No, not really. So there are a lot of problems with this approach. So basically what I've done here is I've said every element is now actually lots of elements. I have every element is a batch of records. And so actually I jumped forward. Hang on one second. So the first problem with this is that it's ugly. The biggest problem is that we have these 2 different steps to do the aggregation, right? So that, that's not great. We first have to do the pandas aggregation and then do the Beam aggregation. But we could actually, we could make that simpler. We could provide tools to like do all of this in one and like just make it a nicer way to write a pipeline. But the bigger problem that I started to jump forward to is that this breaks the Beam model, right? Now I have multiple records in an individual element going through my pipeline. And so I can't have a single event timestamp to represent like what that record is. So if I wanted to do windowing or anything like that to actually have a streaming pipeline or even do windowing in a batch pipeline, I couldn't do that. And that's the only reason I'm able to do this. And so that being said, like if this is a use case that you're doing, like if you have a bunch of data and you want to use Beam on it to process it in a batched way, like this is something that you could maybe do and get some performance improvements. And it could be a win for you. But I don't think it's the right thing for us to sort of encourage people to do in Beam in the long term. So then the question is, what is the right thing for us to do in Beam? So I think really the right way for us to integrate Arrow in into Beam in the future is that it should be a coder or something like a coder that basically encodes rows. So rows are the concept of like something that has a schema in the schema API in Java. And so if you were able to encode those rows in the arrow format, then you would actually be able to process that data. And then the way that would work is that you would actually, if you were processing a P collection of rows, you could have this row instance that was really just a view into your arrow buffer. So you could have a bunch of row instances that actually just are references into the various places in arrow memory. So if you wanted to write like sort of a row-oriented do fun, you would be able to do that just by processing that row. But then if you wanted to be able to write a batch do fun, we could add an interface like a batch process element or process element batched or something that would actually give you the entire arrow record batch. And then you could write some vectorized do fun that operates on all of that. And so, yeah, so I wanted to think about, so if we did sort of go this route, like what would the future look like? So this is my vision of the glorious future where we have schemas and doing things with arrow. So this is an entirely made up API, I will say. So this is the kind of a inglorious combination of like the Python SDK and what exists now in the Beam schema API in Java. But so the idea is, you would read from Parquet, and this would actually produce a P collection of rows, and those rows would actually just be like views into your arrow buffer. And then you would pipe that into all these schema-aware transforms. So like compute column adds the extra computed columns, filter by does the filtering, group by for the aggregations. And all of these transforms would be aware of rows and then also of arrow. So you'd be able to actually do optimized computation on the actual arrow buffer. Or actually the way you could do this is you could just use SQL, right? So at the beginning I showed you a SQL string. We have a SQL transform in Beam. We could just use that maybe. So you could read from Parquet in the same way, produce rows that are actually backed by arrow, and then pipe that into a SQL transform with the argument of just the SQL string that I showed you before. And yeah, this is a mostly fictional API. It's more like science fiction, I guess, because we have a SQL transform in Java. We're starting to work on cross-language transforms. So this is something that is conceivable to have in the near future, to have this SQL transform in Python. Okay, so yeah, the key takeaways, I guess, from my talk are, if you don't care about event times and you just want to run some batch pipeline, you're not doing windowing or anything, you could actually, we could start to add more IOs that produce arrow data like that, and you could do things with arrow in Beam today. So that's pretty exciting. But really, in the long term, to integrate arrow effectively, I think we need a better concept of schemas and schema-aware transforms. So like, we need to do some of the things like Etienne was talking about, like figure out how we can have a schema for like windowed values, make schemas portable, have them in the Python SDK. So all these things need to get fleshed out before we can really use arrow effectively in Beam, I think. All right, that's all I have. So any questions?